All right, guys, let's talk about stuff that is going to be on the test versus stuff that's not going to be on the test. Let's go over what things mean, what words mean, how to do all of the stuff, so you guys are prepared for your test tomorrow. The only thing extra is just the 2.4 stuff. But there's none of the given a point and a vertex, find the A and write the equation. I didn't put one of those on there. We kind of tried to streamline the 2.1 to 2.3 stuff and focus more on the 2.4 complex number stuff. So if they ask you to solve something using the remainder theorem, what's the only thing we care about? The remainder, okay? So they're telling me go ahead and evaluate. Now, a lot of you, where you had mistakes on your quiz, is you forgot the placeholders. So I put 5 in the corner, yes? What is the coefficient of x to the 4th? 4. What is the coefficient of x to the 3rd? Negative 16. What is the coefficient of x squared? 5. What is the coefficient of x? 0. And then what's your constant? 9. You've got to account for all that. You can, if you miss a placeholder, then that's where you're going to make a mistake on this. And this is really simple now. What do? I bring down my first term, 4. I multiply to the corner. And I add down. So 5 times 4 is 20. What's negative 16 and 20? 4. 4 times 5 is 20. 20 and 5 is 25. 25 times 5 is 125. 0 and 125 is 125. What's 125 times 5? 625. And then what's 625 plus 9? 6 what? 634. So how do we answer this? We say f of 5 equals 634. That's it. Anybody have any questions on that? When I'm done, I'll even pull up the test and tell you like stuff that you don't have to worry about. Okay. On the review, there's 2 of these rational root theorems. Find all the real roots. If you guys notice here in example 3, right? The leading coefficient is 3. It's not a 1. You will not have one like that. You will have one similar to number 4 where the leading coefficient is 1. So you don't have to worry about fractions and all that. Now, there isn't a constant here, is there? No. But when you have any of these problems, what should you do first? You should try to factor it. So when we factor, what's the first thing we look for? A GCF. Is there a letter and or number that every single term has in common? X. If I take out the x, I then have x to the 4th plus 6x squared minus, that should be cubed, sorry. 6x cubed, 9x squared minus 44x minus 30 equals 0, correct? How many answers should I have for this question? 5. What's the highest exponent you have? 5. All right, we already know one of them. X equals what? 0. We took it out. But you don't have to worry about that right now. We can deal with it at the end. So there's nothing else I can do factoring-wise. I can't group or anything like that. So I have to do RP over Q. I take the factors of the last number. What is the last number? 30. So I have plus minus 1, 2, 3, 5, 6, 10, 15, and 30. As soon as I try my synthetic division and I don't get 0 as a remainder, as soon as I realize that, just go to the next one. So let's start with 1. What are the coefficients, guys, of what's in the parentheses? 1, 6, negative 9, negative 44, negative 30, okay? So let's try 1. 1 times 1 is 1. 6 and 1 is 7. 7 and 1 is 7. Negative 9 and 7 is negative 2. Negative 2 and 1 is negative 2. Is this going to give me a remainder of 0? Yes or no? No. So then go to negative 1. Same thing. 1, 6, negative 9, negative 44, negative 30. Bring down the 1. 1 times negative 1. Negative 1. 6 and negative 1 is 5. 5 and negative 1, negative 5. Negative 5 and negative 9, negative 14. What's negative 14 and negative 1? Positive 14. What's negative 14 and 14? Sorry, negative 44 and 14. Negative 30. What's a negative 30 times negative 1? Positive 30. So negative 30 and positive 30 is 0. So what did you guys just prove? What's one of my answers? X equals negative 1. All right, so write that over here. X equals negative 1. So what do we do with this leftover stuff? Can I write it as a polynomial? What would I write it as? X to the what? 1x to the third plus 5x squared minus 14x minus 30 equals 0. And then we hope that this does what? We hope it groups, but does this one? No. So what do we have to do again? The P over Q. So plus minus 1, 2, 3, 5, 6, 10, 15, and 30. So start with 1. 1, 5, negative 14, negative 30. Bring down your 1. 1 times 1 is 1. 5 plus 1 is 6. 6 plus 1 is 6 times 1 is 6. Negative 14 and 6 is negative. Is this going to give me a 0 as a remainder? No. So go to the next one. 1, 5, negative 14, negative 30. Bring down your 1. 1 times negative 1? Negative 1. 5 minus 1 is 4. 4 times negative 1? 4 times negative 1? Negative 4. Negative 14 and negative 4 is this going to give me? No? Okay. So let's go to 2. 1, 5, negative 14, negative 30. 1 times 2 is 2. 5 plus 7, 5 plus 2 is 7 times 2 is
14.
Negative 14 and positive 14. 0. 0 times, is this going to work? No? Well, this is annoying. Let's try negative 2. So 1, 5, negative 14, negative 30. 1 times negative 2. 5 and negative 2. 3. 3 times negative 2. Negative 6. Negative 14 and negative 6. Negative 20. Negative 20. Is this going to work? No. So now what should we try? We'll try 3? Okay. So 1, 5, negative 14, negative 30. 1 times 3 is 3. 5 plus 3 is 8. 8 plus 3 is 8 times 3 is 24. Negative 14 and 24 is 10. 10 times 3 is 30. Did this one work? Yes. So what's another one of my answers? X equals 3. Is this problem really super duper hard? No, it's just annoying. But I promise you, God bless you, you will find the 0. I promise you, you will. I'm not going to give you one that absolutely, it's x to the 5th power and has no zeros. I'm not going to do that. So what do we do with what's left over here? X squared plus 8x plus 10 equals 0. And we hope that this does what? Factor. Does it? No. Are there factors of 10 that are going to multiply to give you 10 and add to give you 8? Some of you are sitting here like, are you serious? Are you really going to make us do this on a test or a quiz? I don't know for sure. I haven't worked them all out. But you need to understand the process. What would we do here with the x squared plus 8x plus 10 if it doesn't factor? The quadratic. So we have negative 8 plus or minus the square root of 8 squared minus 4 times 1 times 10 all over 2. So negative 8 plus or minus 64. What? Minus 40 over 2. So negative 8 plus or minus, what's 64 minus 40? 24 over 2. Okay, the question asked at the beginning for all of the real roots. Is this going to be a pretty root? No, but is it real? How do you know it's real? There's no negative. If they ask for all the real roots, and at this point there was a negative underneath the radical, would you have to continue? No, because you'd know that it was imaginary. Good. Good job, guys. All right, it's real though, so we're going to keep going. Negative 8 plus minus. What can I break 24 into? 4 and 6. Negative 8 plus or minus 2 root 6 over 2. And this is where we fall apart. We don't know how to simplify this. Best thing to do is take out the GCF. What do they have in common in the numerator? A 2, right? Can 2 go into 8 and 2 go into 2? So take out the 2. You're left with negative 4 plus or minus the square root of 6 over 2. And then do you see how the 2's cancel? So they cancel. So you have 2 more answers there. They happen to be gross, and you can just write it as plus minus. I don't care. So negative 4 plus or minus the square root of 6. How many answers in my red, yellow, and green do I have? I have 4. But how many did you tell me we had at the beginning? 5. Where is the 5th one? Why is x equals 0? Did we factor it out right there? So you have x equals 0 as well. That is a hard problem. I think the one on the test is going to be like that? No. But you need to understand how to approach solving at the beginning. We're looking for GCF. Take out what they have in common. If you factor something out, go ahead and set that equal to 0 because that will be one of your answers. Then use synthetic division. If you get 0 as a remainder, then you're like, oh, perfect, this one works. If you don't get 0 as a remainder, go to the next factor. And then at the very end, if you have to use the quadratic formula, you're going to have to do that. Because, guys, remember, you're going to have the quadratic formula. There's going to be a question on the test that you have to use it. Yeah. Sure. All right, let's look at 5 and 6. All right, 5 and 6, all you're doing, guys, is just basic algebra. Basic computation. Real stays with what? Real. Imaginary stays with imaginary. When we see I squared, we cross it off and put negative 1, right? You cross it off, change the sign. So what do we do first here? I would not distribute the negative first. I would go ahead here and FOIL. I have negative 8 minus, then I'm going to go ahead and FOIL this. So what is negative 7i times 6? Negative 42i. Perfect. Negative 7i and a positive 10i. Negative 70i squared. As soon as I see I squared, what do? Cross it off and change that sign. Do that right when you see it so you don't make a mistake. And now we're going to say 11 times 6. 66, good. And then 11 times 10i. 110i. All right. Combine like terms. Real with real. What's 70 plus 66? 136. Okay. What's negative 42i and 110i? What's 110 minus 42? Positive or negative? So plus 68i. You guys with me? So I have my negative 8 out here and a minus. Now what can I do with that minus sign? Distribute. So negative 8 minus 136 minus 68i. And what can I combine? The negative 8 and the negative 136. What does that give me? Negative what? Minus 68i. Okay, is that written in standard form? Perfect. Freddie said he did it the other way. He distributed the negative first, and you got the same answer? It's fine. All right, let's look over here. There's a lot going on. There's a lot going on. First of all, 9 minus 4i squared. What does that mean? There's 2 of them. Good, London. You don't just distribute the 2. So I'm going to rewrite this as 9 minus 4i times 9 minus 4i plus 17i minus 19 minus 5. What can I go ahead and combine just right off the bat?
The 9 minus 4.
What would be even easier to do first? What's 19 minus 5, guys? Okay, that's not a trick question. What's 19 minus 5 right here? This is 14, right? So it's just really minus 14. Simplify where you can. This is plus 17i minus 14. Now just FOIL. What's 9 times 9? 81. What's 9 times negative 4i? Minus 36i. What's negative 4i and 9? Minus 36i. And what's negative 4i and negative 4i? Positive 16i what? Squared. Cross off the I squared and do what? Change the sign. Now you've done all your distributing and all that stuff. Now we just say real with real. So I have 81 minus 16, which is what? What's 81 minus 16?
60.
What is it?
65.
Okay, and then minus 14. 51, okay, so 51. And then I have negative 36 and a negative 36. Negative 72i, and then plus 17. 55? Okay, so minus 55i. Is that written in standard form? Yes. Guys, real stays with real. Imaginary with imaginary. Your mathematic basic computation rules don't change. You still FOIL when you're multiplying, that sort of a thing. Real stays with real, imaginary stays with imaginary. Anybody have any questions on that? Yep.
So 9 minus 4i squared, isn't it supposed to be a plus 10 minus?
That would be something different. The problem, how it's written, is telling you that you have 9 minus 4i twice. Multiplying by the conjugate would be the difference, but it's written as you have the same thing twice. All right, bringing that up, Nick, that was good. What do I do here? What's the problem in this problem? What's the issue? I in the denominator, right? How do we get the denominator to not have an I? By the opposite, the conjugate. Now, if you don't like that the I is written first and you want to rewrite it, you can. You could write that as negative 2 plus 10i. Or you can just leave it and fix it at the end. But what would be the conjugate of 10i minus 2? No, you change the sign in the middle. 10i plus 2. If you want to change it first to negative 2 plus 10i, then multiply by negative 2 minus 10i, you can. Or you could just leave it like that and then fix it at the end. But you have to multiply by the conjugate. And when we multiply by the conjugate, what will happen to the i's in the denominator? They cancel out. So go ahead and simplify the denominator first just to make sure that happens. What is 10i times 10i? 100 what? I squared. As soon as I see I squared, what do? Cross it off and change the sign. Do that as soon as you see it so you don't forget. So now I have 10i times 2 is plus 20i, right? Negative 2 and 10i is minus 20i. And negative 2 and a positive 2 is minus 4. Did the i's cancel out? Yes. Do I have two real numbers that I can add together or subtract? Negative 104. Perfect. You should always simplify the denominator first so you make sure that you multiply by the right thing. And now let's just go to the top. What's negative 8 times 10i? Negative 80i. What's negative 8 times 2? Negative 16. What's I times 10i? What's I times 10i? Plus 10i squared. Oh, I see an I squared. What should I do? Cross it off and change the sign. Do that right away so you don't forget. And then the last thing I have is what? Plus 2i. We combine real with real, imaginary with imaginary. So what are my two reals? Negative 16 and a negative 10 is negative 26, good. And then I have negative 80 and a positive 2. Negative 78i. At this point, you should try and simplify. Take out a GCF. What number goes into both 26 and 78? 2? Yeah? You want to take out a negative 2? That's fine. It doesn't matter. To take out a 2. What's negative 26 divided by 2? Negative 13. Minus, what's 78 divided by 2? 39, okay. Over, what's 104 divided by 2? 50 what? 50, say it again. Now do the 2's cancel? Yeah. If you get to this point and don't simplify, don't freak out. Might be a pointer to it, not a big deal. But understand the concept. How do we get rid of the i's in the denominator? Multiply by what? The conjugate. Good. All right. This is a quadratic. It's going to say to solve. In order to solve a quadratic, what's the first thing you have to make sure that the equation is in? Standard form, okay? Don't just go, oh, that's A, B, and C. Write it in standard form, because when you have something on one side of the equal sign and you move it to the other, remember the signs change. So this actually is positive 7x squared minus 6x plus 2 equals 0. Go ahead and try and solve it by factoring. Are there factors of 14 that multiply to give you 14, add to give you negative 6? No. So we got to use the quadratic. So it's negative b. So I have a negative 6 plus or minus the square root of b squared. So negative 6 squared minus 4 times a times c all over 2 times a. Hardest part of the quadratic formula is just plugging it all in correctly. Now just take your time and simplify. Negative, negative gives me positive 6 plus or minus. What's negative 6 squared? Good, 36. Minus, what's 4 times 7 times 2? 28 times 2 is? Right? 4 times 7? So 56 here. All over 14. Everybody with me? Okay. So 6 plus or minus, what's 36 minus 56? Negative 20 over 14. I'm going to go down now. Remember, guys, that negative, what do we have to do with the negative? We're going to take it out. So think about it. 6 plus or minus negative 1 times 4 times 5, right? You guys agree? Okay, so think about it independently, and then maybe you won't make a mistake. What's the square root of negative 1? I. What's the square root of 4? 2. So this becomes 6 plus or minus 2i root 5 over 14. And then always check to see if you can simplify. Take the GCF out of the top. What number goes into both 6 and 2i root 5? 2. Okay, so 6 divided by 2 is 3. Plus or minus 2 divided by 2 is 1. So I root 5 over 14. So what's my final answer? Two goes into 2 once. 2 goes into 14 how many times? 7. So it's just 3 plus or minus I root 5 over 7. Questions? All right, we're almost done. I think the review is a little harder than the test is going to be. Just make sure you know how to do everything. Don't worry about the numbers being huge or anything like that. All right, most of you did really well on this question on the quiz. This wasn't where you guys had an issue. What can we answer just by looking at this right now? The domain, what is it? Negative infinity to positive infinity. Another thing we can do right away. The y-intercept, where is this cross? At 0, 1. Guys, I told you, write your intercepts as ordered pairs. We can also see what kind of a parabola we have. This one's going which direction? Up. That means my axis of symmetry is at the x part of my vertex. I have a minimum value at y equals the y part of my vertex. And then what do we notice about the range? Is it going to be from negative infinity to the y part of the vertex or y part of the vertex to infinity? Y part of the vertex to infinity. Perfect. Yep. Okay, so when we talk about range, this is negative infinity. Here's the vertex, and here's positive infinity. So where does this graph, where does it lie? In between negative infinity and the vertex, or from the vertex to infinity? Do you see where it is actually? That's how you know. If it's a negative parabola, it'll be negative infinity to the vertex. All right, so let's go through the motions. You guys, we all know how to do this. Come on. How do you find the x part of the vertex? X equals negative b over 2a, correct? So I have negative 2 over 2 times 4. Negative 2 over 8, which is what? Negative 1/4. Okay, good. That's the x part of your vertex, negative 1/4. That's also the axis of symmetry. X equals negative 1/4. So how do I take that and find the y? Plug it in. So y equals 4 times negative 1/4 squared plus 2 times negative 1/4 plus 1. Okay, take this, go here and here. So you have 4 over 1 equal times 1 over 16. Yeah. Minus what? 2 over 4. You can, yes, go to 1/2 if you want. I'm just going to leave it as 2 over 4 because we're going to have to get a common denominator anyways. And then I have plus 1. Everybody with me? All right, let's simplify that first part. Can I simplify the 4 and the 16? Yeah, 4 goes into 4 once. 4 goes into 16 4 times. So you have 1/4 minus 2/4 plus how many fourths? 4/4. Good. So the hardest part of this question is this part. And it has nothing to do with pre-cal. What's 1 minus 2? Negative 1 plus 4. Perfect. So 3/4. Whew. So 3/4 is here. What's my range? 3/4 to infinity. Where's my minimum value? Y equals 3/4. Good. Can I do my vertex form? Yes. What's my A term? 4. So your vertex form would be f of x equals 4. And then you have x minus what? Negative 1/4. So it'd be x plus 1/4 squared plus 3/4. We just answered all of those questions just by finding the vertex and looking at the equation. And then the last thing we have to do is find the x-intercepts. And how do we go about doing that, ladies and gents? You equal to 0 and you factor. 4x squared plus 2x plus 1 equals 0. Please factor. 4 times 1. What are the factors of 4 that multiply to give me 4 and add to give me 2? It doesn't. So we have to use what? Quadratic formula. So negative 2 plus or minus 2 squared minus 4 times 1. All over 2 times 4. Negative 2 plus or minus the square root of 4 minus 16 over 8. I'm going to stop right there. It's imaginary. Very good. How do you know it's imaginary? Correct. 4 minus 16 is negative 12. So what does that tell me about my x-intercepts if I get an imaginary number? There's none. Remember, x-intercepts are real zeros, where the graph actually crosses the x-axis. If you get an imaginary, that means it doesn't cross. It means when your U-shape is just above the x-axis. Don't continue solving it and then put that answer on the line, because that's not the correct answer. All right, this is where a lot of us went a little awry. I'm not exactly sure why, but that's okay. If you're finding end behaviors in action at the x-axis and all that stuff, think about, what do I have to make sure that my function is first before I determine any of this stuff? Standard form. All right, so is this in standard form? Yes, my highest exponent's first. Okay, perfect. So look at your highest exponent. What kind of a number is that? It's odd. So when I think odd, I think of what? Opposite. So the end behaviors of a graph are going in the opposite direction. Is this a positive or a negative? It's a negative. So what does that tell me? It's going to resemble, think about the ends of a negative line. So here is the left-hand side, here is the right-hand side. What's happening on the left? It's going up or down? Up or down? Up. So we say rising. We don't say going up. We say rising left and doing what? Falling right. Perfect. Does anyone have any questions about that? If the highest exponent is even and it's a positive function, which way are the arrows going? Both up. If it's an even function and it's negative, both are going which direction? Perfect. Okay, good. All right, zeros. How do you find the zeros? You set your equation, what? Equal to 0. How many answers should I have for this question? 5. My highest exponent is what? 5. When we factor, the first thing we look for is the GCF. What can I take out of negative 3x to the 5th and a 27x cubed? I'm going to take out negative 3x cubed. So I have negative 3x cubed. And then what am I left with? X squared minus 9. Perfect. Can I factor x squared minus 9 a little more? X minus 3x plus 3. Perfect. Yeah, set them all equal to 0. So I have negative 3x cubed equals 0. X plus 3 equals 0. X minus 3 equals 0. Guys, divide by negative 3. I have x cubed equals 0. How do I get this answer? I take the what? The cube root, yep. What does that mean, the cube root? You have 0 how many times? Perfect. So when it asks for multiplicity, just point to it. How many times do you guys have 0? 3 times. How do you know it's 3 times? Because you took the cube root. If you took the 4th root, you'd have 0 how many times? 4th root. How many times? 4. If you took the 9th root, how many times did you have 0? 9. Okay. And then solve these other ones. X equals what? Negative 3 and x equals positive 3. How many times do you have negative 3? 1 time. How many times do you have positive 3? 1 time. Okay, good. That's fine. Guys, I'm totally okay with that with multiplicity. Some of you wrote me like 3 sentences. I don't need all that. I don't like all the words. Just tell me how many times you have each. Now, what does that mean? Remind me again about multiplicity. If you have a multiplicity an even amount of times, if you have the same answer twice, 4 times, what is your graph going to do? It's going to bounce. If you have multiplicity an odd number of times, or if you only have things once, 1 time, 3 times, 5 times, what's your graph going to do? It's going to go through. Perfect. So I have negative 3, 0, positive 3. Go back to the beginning. What did you tell me the end behaviors were? Rising on the left. So put an arrow going up. And doing what on the right? Going down. And what did you just tell me is going to happen at all 3 of these points? It's going to go through. So just follow, watch, go through, come back through, come back through. That's it. Now, I just answered all of the questions here, which is fine. You don't have to write it all on the line. I can follow what you're doing if you draw me a map. Do you guys have questions? Anybody have any questions? No? Okay. There's going to be a question like this on your test, and this looks like, oh my gosh, so much is going on. Just take everything one step at a time, all right? Let's simplify. Let's figure out what's real and what's imaginary. So I have negative 4 here times negative 1 times 49. Do you guys agree? Yes? Okay. So plus 5 times, what's the square root of 81? 9. Okay. Minus 15i minus 3 times, this is going to be negative 1. What can I break 27 into? 9 times 3, okay. Plus 2, what can I break negative 75 into? Negative 1 times what? 3 and 25. You want a perfect square and a non-perfect square. All right, so do you guys see, why is it important to separate the number from the negative 1 when it's underneath the radical? Correct. So let's simplify this first part. Square root of negative 1 is I. What's the square root of 49? 7. So you have 7i times negative 4 is what? Negative 28i. Perfect. Keep simplifying. What's 9 times 5? 45. Can you combine those two things? Can you combine negative 28i and positive 45? No, why? One's imaginary and one's real. Good, okay. So minus 15i. Then I have minus. Let's simplify here. Square root of negative 1, I. Square root of 9 is 3, right? So we're going to multiply. 3 times 3i is 3 times 3? 9 with a what with it? So minus 9i square root of 3. And then I have what? Square root of negative 1, I. Square root of 25, 5. So I'm going to multiply 2 times I times 5 is 10i square root of 3. Everybody with me? Now you can combine anything that's imaginary with anything that's imaginary. You can combine imaginary with roots if they have the same root, that sort of a thing. So this is just seeing if you guys are paying attention. What should come first? The real, the regular number. So I have positive 45. Is there anything else that's real? No, so you have 45. Now it doesn't matter. You just put the imaginary second. But do you understand why you can combine these two? They both have what in their, they just have an I. Why can't I combine it with the square root of 3? Because it's not the same, it's not like terms. This like term is I root 3, and this one is I root 3. So you can combine those two. But just because it has an imaginary, same rules apply. You wouldn't say that 3 plus 2 square root of 2 combined to be 5. That doesn't work like that because they both have to have the same radical. Does that make sense? So what's negative 28 and a negative 15? Negative 43 what? I. Good. And then what's the last bit? What's a negative 9i and a positive 10i? Plus I square root of 3. You cannot combine any more. This is real. This is imaginary. And this is imaginary with a root. If the roots are the same and it's imaginary, then go ahead. As long as it's like terms, but you cannot go any further than that. So just be like this. So you're going to have something like that on your test. Make sure you guys understand what can be combined. Any questions?